Welcome to today's lesson. My name is Yamasaka Kriandens. I'm going to take you through today a lesson on actually organic chemistry, and in particular, we'll look at the alcohols. So we go straight into the lesson. Okay, actually, our alcohols are a homologous series in which a hydrogen atom of an alkane is replaced by a hydroxyl group, which is the oxygen and the hydrogen. So a homologous series here actually simply means that these species or these compounds from the same homologous series will have a similar general formula. But there are other properties of homologous series that we are going to actually describe in detail in the next lesson. But I've just stated one here that actually homologous series has a similarity in the general formula. And so alcohols have the same general formula. Similarly, alkanes and alkenes are homologous series because they have the same general formula. Okay, so in naming alcohols, actually we look at the alkane and the E at the end of the alkane, we replace it with the OL. That is as simple as that. So, and then we'll look at now the molecular formula as well as the structure formula. So we'll look at the three aspects, namely giving the molecular formula as well as the structure formula of an alcohol. And so the general formula for an alcohol is actually, as stated here, we have the carbon, then N, the hydrogen, 2N plus 1, and then the hydroxyl group, which is OH, which is the oxygen and hydrogen. And so this is the general formula, that is CnH, 2N plus 1, then you add the hydroxyl group. So let's start now, Nemi. We'll start with the methanol. Methanol has only one atom here of carbon, so you put 1. Then on hydrogen, it would be 2 times 1, which is 2 plus 1, 3. And then you add the hydroxyl group. So this is the molecular formula for methanol. For ethanol, you do the same. For ethanol, it has 2. So you're going to put 2 here. Then 2 times 2 plus 1, which is actually 5. So we're going to have the carbon here 2, then hydrogen 5, and then the hydroxyl group, which is OH. Then I will not do with the propanol. I'll go straight into butanol because these are the same methodologies. So this one will have 4. So it means that when we go, we'll have 4 there. And then hydrogen, it will be 2 times 4, which is 8. 8 plus 1, which is 9. And then you add the hydroxyl group. And so you get carbon 4 atoms, hydrogen 9, and then hydroxyl group, which is OH. So this is basically how you can name the actually alcohol, as well as give it the molecular formula from the general formula. And you note that all the alcohols, they end in OL, as you can see from here, they end in OL. And now we go straight into actually from the name and the structure formula. From the molecular formula, we'll be able now to write the structure formula. So we'll start with the methane. So methane here, we have 1 carbon atom. So you start with writing the carbon atom, and then you write a bond, and then you write oxygen, a bond, and hydrogen. That is, first of all, you write the carbon atoms and the functional group, which is actually the hydroxyl group. This is very important because the structure changes once the hydroxyl group changes its position. So we have to start with it first of all. And then around the carbon, you write 4 bonds. So there'll be this bond, there'll be this bond, there'll be this bond, and this bond, and then put hydrogen. So there will be how many hydrogen atoms? 1, 2, 3, 4. So even here we have 3 plus 1, 4 hydrogen atoms. So this is the structure for methanol. So the structure for ethanol, you start with the carbon atoms, right? The carbon atom, 1 single bond, carbon atom, 1 single bond, then oxygen, 1 single bond, hydrogen. And then around the carbon, you write the bonds. 1 bond there, 1 bond there, 1 bond there, 1 bond. 1 bond there, 1 bond there, 1 bond, and there should be 4 for it to actually attain the octet state, that for stable configuration. Around the carbon atom, there should be 4 electrons. And so this is the structure of ethanol. Similarly, now propane 1OL, because now this functional group, why we are stating actually with 1, meaning that this hydroxy group is on carbon number 1. It can be either from here, it will still be on number 1, or this side at the end, it will still be on number 1. But when we shift the hydroxy group into carbon number 2, it will change the name as well, because the structure actually changes. And so we write, first of all, the carbon atoms, the carbon atom, bond, carbon atom, bond, carbon atom, bond, and the hydroxy group, oxygen, bond, hydrogen. And around each carbon atom, you write 4 bonds. So there's this bond, this bond, this bond, and this bond. Then you put hydrogen there, hydrogen there. This bond, that bond, that bond, that bond. Hydrogen there, and hydrogen there. This bond, this bond, this bond, and this bond. Hydrogen there, and hydrogen there. So you can cross-check your answer whether you have the same number of atoms for hydrogen and carbon. For carbon, we have 3, 1, 2, 3, these are the ones. And for hydrogen, there are 8, 7 plus 1, 8. So we can count 1, 2, 3, 4, 5, 6, 7, 8. And for oxygen, 1. So this is the structure formula for propane 1OL. The structure formula for propane 2OL is that first of all, write the carbon there, bond, carbon, bond, carbon. And then you write bond, oxygen, bond, hydrogen. So we have seen now the hydroxy group has come on carbon number 2. And therefore, that's why we put a 2 there. And then we put around each of these carbon atoms 4 bonds. 1, 2, 3, 4. Put hydrogen, hydrogen, hydrogen there. Put a bond there, hydrogen. Put a bond there, hydrogen. Put a bond there, hydrogen. Put a bond here, hydrogen. There should always be 4 bonds around each carbon atom. And so you can cross-check here. There are 8. Similarly, 1, 2, 3, 4, 5, 6, 7, 8 atoms of hydrogen, and 3 atoms of carbon, and 1 atom of oxygen. You note here that the general formula or the molecular formula is the same for propane, though the structure formula is different. So this is what is known as an isomer. An isomer is a compound with the same molecular formula and the different structure formulas. So the structure formula is different, but the molecular formula is the same. So we go to but1OL. So you actually draw, you write the 4 carbon atoms, carbon atom, bond, carbon atom, bond, carbon atom, bond, carbon atom, bond, then hydroxy group, oxygen, bond, hydrogen. And around each of these, you write the 4 bonds around each carbon atom. Okay, so here actually the hydroxyl group is on carbon number 1. If it comes this side, it will still be on carbon number 1. If we bring it here, it will be on carbon number 2. Again, from this side, if we bring it here, it will be on carbon number 2. And so, where it is here, it's on carbon number 1. That's why I put butane 1-OL. So now we have butane 2-OL. So this hydroxyl group has come on carbon number 2. It doesn't matter. If you wanted, you would have brought it here. It will still be on carbon number 2 starting from this side. Or from this side, it's on carbon number 2. So you draw the 4 carbon atoms, carbon, bond, carbon, bond, carbon, bond, carbon. And then the functional group, bond, oxygen, bond, hydrogen. And then you fill in now for each of these around them. Bond there, hydrogen, bond, 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 hydrogen. And there should be actually 10 of them. So you can count them or verify. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is correct. And so this is actually a brief lesson on how to actually name the alcohols, giving them a name, as well as giving them the molecular formula and the structural formula. From actually, we get the molecular formula from the general formula. So this is very important because if we miss this step, when we'll be looking at now how these alcohols can react with the other compounds, it will be difficult for us to proceed. And so we need to know the basic concepts of how to name the alcohols, how to give them the molecular formula, how to give them also a structural formula. Okay, so I hope you have understood this lesson. And so proceed to subscribe to my YouTube so that you can be receiving these lessons. I thank you.